We can access elements in a data frame in different ways. In general, we can access rows, columns, or individual elements by using the row and column labels. Let's see some examples. Here's a data frame we created in the last video. We can access the bikes column using the column label like this, and use a list of the column labels to access multiple columns. We can access a row using the row index label, and the value at a specific row and column like this. It's important to know that when accessing individual elements in a data frame, like in this last example, the column label always comes first, and then the row label. If you provide the row label first, you'll get an error. We can also modify our data frames by adding rows or columns. Suppose we decided to add a shirts column to our data frame. To do this, we can define a shirts column containing the quantity for each of the 2 store rows like this. This added a new column to the end of our data frame. We can also add new columns using arithmetic operations on other columns of our data frame. For example, we can create a new column called suits by computing the sum of the shirts and pants column. Suppose now that you opened a new store and you want to add that as a row on your data frame. To add rows to our data frame, we first have to create a new data frame with those rows and then append it to the original data frame. Let's see how this works. Here is a dictionary of the items in our new store that we will use to create a data frame. We can now add this row to our store items data frame using the append method. After appending to the data frame, the columns have been placed in alphabetical order. We can also add new columns to our data frame by selecting data that already exists in our data frame. For example, let's say you want to stock stores 2 and 3 with new watches. So you decide to add a new column called new watches to your data frame. And say you want the quantity of these new watches to be the same as the watches already in stock. Since we only want to stock stores 2 and 3, we can index them like this. It is also possible to insert new columns into the data frame anywhere we want. The insert method allows us to specify the location, label, and data of the column we want to add. Let's use this to add a new column called shoes right before the suits column. The first argument is loc, or location. We put 5, so 0, 1, 2, 3, 4, 5. So we actually inserted the shoes column before the watches column. The second argument is the label, and the last is the data. In addition to adding rows and columns, we can also delete them. We can use the pop and drop methods to do this. The pop method allows us to delete columns, while the drop method can be used to delete both rows and columns by using the axis keyword. Let's see some examples. We can delete the new watches column using pop, which is used to remove columns. Now we'll remove the watches and shoes columns with drop, which can be used to remove columns if we set axis to 1. We'll use that same method to remove the rows store 2 and store 1 by setting axis to 0. Sometimes we might need to change the row and column labels. Let's change the bikes column label to hats using the rename method. This takes in a dictionary with the original label as keys and the new labels as values. We can see that bikes has been renamed to hats. Now let's change the row label using the rename method. We can change the index label of store 3 to last store like this. Notice here we set the index parameter to the dictionary, whereas in the previous cell we set columns to the dictionary. We can also set the index to be one of the existing columns in the data frame like this. Now we're using the values in the pants column as our row index labels.